This is Dr. B, and here's the story of Bohr's epiphany, where it was determined where the electron is around an atom, at least a hydrogen atom, and what it's doing there. It was known since the early 19th century that individual elements in the gaseous form, when turned into a plasma, gave off discrete lines of light, razor sharp. Here's the hydrogen emission spectrum. So you just take some hydrogen, put it in a tube, run a little current through it, and you see that it's always emitting only those wavelengths of light. There's got to be some very useful information. I mean, why is it doing that? Mathematicians approached it, well, mathematically, and saw those numbers, and they saw that it's a coalescing sort of situation. It follows a pattern. The pattern was eventually determined to be known as the Balmer formula. This is known as the Rydberg constant, and it says that that wavelength in nanometers can be determined. All you need to do is have two whole numbers. We'll call them inner and outer, which is a bit of a reveal. And if you solve this for two numbers, say 3 to 2, you'll get 656 nanometers. So you need two whole numbers. These observed lines have something to do with two whole numbers. What a mystery. Bohr realized, perhaps rather quickly, that perhaps that means that the electron's moving from one fixed position to another. When it does that, here it is going from the second shell to the first shell, it'll emit a packet of light, a photon of light. This, Planck's constant was already known, and so he could maybe realize that photons are not so surprising. And it works so well. If the electron goes from the first shell to the third shell, well, no light's going to be emitted, it's simply absorbing light. But then when it collapses down from the third shell to the second shell, bada bing, you get 656 nanometers, a red line of light, razor sharp. Fourth to the second. There you go. That's your teal colored light. 486. Looks a little greenish there. 5 to 2. Ah, that's the teal one right there at 434. How about even 6 to 2? Will give rise to, I think it's at 410 nanometers. This will work from any wavelength to any wavelength, but it'll go, when you're in the second shell, it's when you get the visible light. This became known as the visible series. There's also other series, right? There's the infrared series, there's the ultraviolet series, and I'm sure there's others as well. It works super cleanly, and it's a beautiful model for the atom. It's simply atomic emission is where light comes from, right? It's where electrons going from outer shells to inner shells. Be warned that this only works cleanly for one electron systems. When you have more electrons involved, things get much more complex. But this was the initial understanding of where electrons are in atoms. This is the story of Bohr's epiphany.